Hi everyone, and welcome to a very quick review of index laws. We've got 3 examples here that we're going to have a look at, and these should show you most of the skills that we've learnt in previous years. The steps that I always like to remember are down the side here. I always like to do prime decomposition first on larger numbers, so that we're dealing with just bases and powers. I then deal with the brackets. I then look at the negative powers and make them positive. Then we start to simplify, top with top, bottom with bottom, and then we do our final simplification, top and bottom. Remember, if you don't need these steps, you just skip through them. Okay, let's have a look at this first example. There's going to be 2 things that I need to start with. I'm going to deal with that division symbol. And remember, when we're dividing fractions, we times and flip. The second thing I'm going to deal with are these larger numbers, and I'm going to use prime decomposition to make them simpler. So the negative is still a negative, the 2 stays, everything else stays the same. The 4 is going to change to 2 squared. Now when we come to the multiplication, that division is going to be multiplied now, and we're going to flip the second fraction. So the 25 is going to be on the top, and instead of writing 25, I'm going to write 5 squared. And then a to the 5, b to the 3. Now on the bottom, it's all going to stay the same, but instead of writing 10, I'm going to write 2 times by 5. Remember, we use the little dot instead of the multiplication. Everything else stays the same. Okay, now I'm going to deal with the brackets. We're going to expand the brackets. Remember, when we're expanding powers across brackets, we multiply the powers together. Now, when we look at this negative symbol here, I actually like to think about the negative as being a separate number. So that's just thinking about it being a negative number. So when it's the power of 3, that's itself times itself 3 times. So it's a negative times a negative times a negative. So in the end, we're going to have a negative number. If that was an even power instead of the power of 3, that would end up being a positive, because it's a negative times a negative times a negative times a negative. When you multiply negatives in even number of times, it becomes a positive. Negative number of times stays as a negative. Then we just leave everything with the powers. So it's going to be a to the power of 6 and b to the power of negative 6, 2 squared. Everything else is going to stay the same. Now we've got this second bracket here. It's going to be 2 squared, 5 squared, a to the 6, b squared. Now the next step, we're going to have a look at those negative powers. Anything that's a negative power, I'm going to make it a positive by flipping it to the other side of the bracket, other side of the division. So everything stays the same. We're just going to flip those negative powers round. Now, next step, top with top, bottom with bottom. So we've got a negative times a positive, so that's a negative. 2's got no one to play with. 5's got no one to play with. A, you have 6 and a 5. You add them together makes 11. B, 3 and 3 makes 6. And then on the bottom, see, now we have 2 and 2. So instead of multiplying together, we just treat them like the base and the power, just the same as we did with the A and the B. So it's going to be 2 to the power of 4, 5 squared, a to the 11, and b to the 8. Okay, now we just cancel what we can out. So let's have a look here. The 5 squares cancel out entirely. The A11s cancel out entirely. And then we just have to look at the powers here to see what we've got left. So what we've got left over, we've got a negative, we've got 2 to the power of 1 on the bottom, and we have b to the power of 2 on top. Now, because we don't have anything left on the top, that means we have to have a 1 there to hold the place. So that's the final solution. Okay, the next question. Now this is an example, it's very similar, but it's just got fractional powers. So what we have to do to start with, I'm going to do prime decomposition, but I'm also going to change those radical symbols, the square roots and the fourth roots, to fractional powers, so it makes it easy to deal with. The 3 can't get any smaller, so I leave it alone. I'm going to change that square root to the power of a half, and I'm going to change that 6 to 2 times by 3. The 4, the power of the fourth root, I'm going to change that to a power of a quarter, and then the 2 can stay the same on the inside. Now the 16, that's 2 to the 4, so I change that, and I leave the power the same. Now we just do the same steps. Expand the brackets. Now you can either use multiplication symbols or dots here, it doesn't matter. And see here, the 4 times by 3/4, the 4's cancel out and you just get left with 3. Now, we just do normal index laws again. Multiplying bases means we add the powers. So 3, you've got a quarter plus a half, that's 3/4. 2, we've got a half and a quarter, that makes 3/4. And then you've got 2 to the 3 on the bottom. Now, just as a little thinking step, to do this in our head so we don't grab our calculator, that's the same as 12 on 4. So 3 is the same as 12 on 4. So when I do that subtraction, when I simplify these, oh, I've written that as a 3, sorry, that should have been a 2. When I do this subtraction here with the powers, I've got 3/4 on the top and 12/4 on the bottom. So what I'm going to get left with, I'm going to have a 3 to the 3/4 on the top, and on the bottom I'm going to have left with 2 to the 9/4. Now that's a good answer, but we could also simplify that a little bit. We could go to another step further. First of all, we could take out the power of a quarter. There's actually a few ways we can write this. So I can say that's 3 to the 3 to the power of a quarter. So just using our index laws going backwards, and that's 2 to the 9 to the power of a quarter. And that means we've got a common fractional power here. So we can put everything to the fourth root. So it's going to be 27 over, I'm just going to write that as 2 to the 9 because I don't have my calculator. Okay, there are a few other ways that you could write that, and they would also be correct. So when you come to these index laws, especially with the fractional powers, there's lots of ways to write the solution. Now with our last one, we've got to simplify, but see that we're working in scientific notation. We can write in standard form to make it easier for us. So remember, in scientific notation, we've got to count the place values. So that's 1, 2, 3, 4, 5, 6, 7. That's 7 there. So that becomes 3.2 times 10 to the 7 times by, now we've got to count the other way, 1, 2, 3, 4, 5. So that's 0.4 by 10 to the negative 5. And then we have 1, 2, 3, 4 over 1.6 times by 10 to the 4. Now, all we have to do here is to start working on our powers. So we can, these numbers here can just be dealt with like we did with the other two questions. So it's 10 to the 7, 10 to the negative 5, and 10 to the 4. I can move the negative 5 down to the bottom. So overall, we've got 10 to the 7 on the top and 10 to the 9 on the bottom. And then I can just look at my numbers. If we've got 1.6 on the bottom and 3.2 times by 0.4, off the top of my head, Okay, just off the top of my head, I'm pretty sure I remember this right. So 3.2 times 0.4 is 1.28. Now we just deal with the numbers again. So 1.28 divided by 1.6 is 0.8, and that number goes on the top. And then we have a 7 and a 9, and we've got 7's on the top, 9's on the bottom. That means we have 2 left on the bottom, or a negative power of 2 on the top, which is the same as if we move that decimal place 2 times. So both of the last two solutions are the more correct one. This is technically correct, but it's not simplified properly. Okay, I hope that helped with your index laws reviews. If you're having more troubles, there is more detailed examples in the next videos. Okay, thanks guys.